Today I am starting a series of lectures on sample size calculations. This is my first lecture on sample size calculations with regard to tests for mean and proportions. This is the reference book from where I have taken sample size formulae. Researchers often decide about the sample size arbitrarily, either as per their convenience or from the previous literature. The question to be answered is whether the achieved sample size has power to detect a desirable effect size. I have lecture on my YouTube channel about effect size. Unduly large and small sample size both have a problem. A small sample size produces an imprecise estimate of accuracy with wide confidence interval, which is non-informative for decision makers in medical context. On the other hand, unduly large sample size is a wastage of resources. If the sample size is too low, the standard statistical test will not have the statistical power to detect differences that really exist. With the decline in sample size, the probability of acceptance of a false null hypothesis, sometimes referred to as beta, increases. So this is the type 2 error or beta. Small sample size increases the margin of error, which can render the study meaningless. So these are the disadvantages of unduly small sample size. Now, if the sample size of the study is too large, then the monetary, temporal, and scheduling costs of gathering the data may be so formidable that only the resourceful can do the research. If the study is a clinical trial involving the random assignment of patients to an experimental group during the toxicity testing phase, then placing more subjects at risk than necessary, even though they might have given informed consent, is almost criminal. Large sample size leads to an exaggerated tendency to reject the null hypothesis with clinically negligible differences. That is, insignificant associations may become significant. So these are the disadvantages of unduly large sample size. This is my lecture outline. I will talk about sample size for assessing significance of single mean, followed by sample size for assessing significance of single proportion. Then I will talk about sample size for assessing significance of two means, that is the difference between two means. Then sample size for assessing significance of two proportions, that is the difference between two proportions. Then briefly I will talk about sample size estimation for chi-square test and for pair t-test. So first of all, let us see the precision approach. This approach is required for sample size estimation for assessing significance of single mean and single proportion. From my previous lectures, the confidence interval is defined as mean plus minus z 1 minus alpha by 2 multiplied by standard error. So this is the confidence interval within which the population mean is supposed to be there. From rearranging this confidence interval, we get the sample size formula as n is equal to z1 minus alpha by 2 multiplied by standard deviation divided by the margin of error. And we do the square of this entire thing. So this range confidence interval is margin of error, which we predefine, and then we calculate the sample size for a particular standard deviation. So this is known as precision approach. So using the precision approach, we get this formula for sample size for assessment of significance of single mean. And this is for assessing the significance of single proportion. This is the sample size. Now the power analysis approach. This is required for sample size estimation for assessing significance of difference between two means and difference between two proportions. The viewers are advised to view my previous lecture on power analysis, which is present on my YouTube channel. This is the address of my YouTube channel. So this is the derivation of the sample size formula from the power analysis approach. If this is the null situation and this is the alternate situation, and we have difference between these two as delta. So if we decide a critical value, so the area under this left curve beyond this critical value is the alpha by 2, and area left to this critical value under the second curve is the beta, and this is 1 minus beta. So this critical value is defined from this side or this side. If critical value is defined from this null side, this is the equation. If this critical value is defined from the alternate side, this is the equation. And equating both these, we get the sample size as n is equal to 2 multiplied by summation of these two, square of this multiplied by a square of the standard deviation divided by the delta. And delta is nothing but difference between the two means. So this is the power analysis approach. So sample size for assessing significance or difference between two means is this. These are the alternate formulas which are available in the literature. If there is unequal sample size and R is the ratio of controls to cases, then this formula can be used. Then similarly, for a case of two proportions, we can derive the formula from power analysis approach. And this is the alternate formula for sample size estimation for assessing significance of two proportions. The difference between the previous formula, this one, and this is that the alternate side is different. So these are the other alternate forms for sample size formula for difference between two proportions. These are other alternate forms which are available, and any one of these can be used to calculate the sample size. Then sample size calculation for chi-square test. Chi-square table, which is like R multiplied by C table, have the proportions, especially in case of 2 by 2 situation. So we have proportions, so we can calculate the sample size based on the sample size formula for difference between proportions, which I have described previously in this lecture. Only in case of continuity correction, we need to alter the sample size using this formula. Then sample size calculation for pair t-test. So this is the formula for sample size calculation for pair t-test. Here D is defined as D is equal to delta divided by standard deviation. And since we have n minus 1 on right side also, this is an iterative situation. So iteratively we can reach to a particular sample size. Viewers interested in detail can go to this website. So this is all for today. Thank you very much.